Today's lesson is on reasoning with properties from algebra, and this is probably one of the most important lessons we've had so far in our course. So if you have any difficulty with this lesson, then by all means don't hesitate to write some issues that you have, questions that you have on your paper so we can discuss it thoroughly in class. All right, so what we have to do when we want to reason, when you're making an argument, you need to have reasons. And our reasons are going to be, like I've told you all year, they're going to be definitions, postulates, theorems, and these properties. These properties here that we're going to talk about right off the bat today. So our first property we want to talk about, if you look here, you can see, what have I done? I've added C to both sides. So hopefully you remember that that is the addition property of equality. All right, if I subtract a number C from both sides of an equation, then of course that's the subtraction property of equality. If A equals B, then AC equals BC. What I've done is I've multiplied both sides of my equation by C, so of course that's the multiplication property of equality. And let's see what we have now. Okay, in this case, we're dividing both sides of our equation by C. So that would be the division property of equality. And all this means here is, remember that our denominator can never be 0. All right, for any real number A, when we say A equals A, that is the reflexive property of equality. And you may be thinking, why do we need a property that says that? Well, we will use the reflexive property quite a lot in proofs, so don't write it off as being meaningless. All right, next, if A equals B, then B equals A. That's known as the symmetric property of equality. If A equals B and B equals C, then A equals C. We of course know that as the transitive property. It looks a lot like the law of syllogism when we're using conditional statements. All right, and then if A equals B, then B can replace A in any equation or expression. That's the substitution property of equality. And finally, what do we have here? Use multiplication to distribute A to each term of the sum or difference in parentheses. That's the distributive property. These properties will oftentimes be reasons in your proofs, so you must memorize them. You have to know what each one says. Make a flashcard for every single one of them. Okay, so we're going to hop right in and we're going to do a proof. A proof, which is a convincing logical argument that uses deductive reasoning to show why a conjecture is true. Okay, there are 3 types of proof. You can have a paragraph proof, a flow proof, and a 2-column proof. We will, in my course, always do 2-column proofs. In all of my courses that I did in college, I never did anything other than a 2-column proof, so I'm going to stick to 2-column proofs here. They just make better sense to me. So let's always, when you start with a proof, you'll have some given information and then you'll be told what it is you want to prove. So right here we're given that 3x plus 1 equals 16. So our reason for writing that in our first step is going to be because it's given to us. How do we know? Basically, you're looking at your statement, and your reason is going to be, how do we know this? Why am I allowed to make this statement? Well, we can make statement number 1 because that's what's given to us. All right, so our next statement, number 2, says 3x equals 15. So what I'm looking at here is, what did I do to statement number 1 to get to statement number 2? Well, I subtracted that 1 from both sides, right? So that's going to be, and I'm going to have to abbreviate here, the subtraction property of equality. And it's okay with me if you abbreviate in your proofs, but when you're abbreviating subtraction, I need for the R to be in it because otherwise I might mistake it for the substitution property. And since we do have some properties of congruence, I would like you to be sure and let me know that it's a property of equality or congruence. All right, so our last step in here, the thing we're trying to prove, the last step of your proof will always be what it is you're trying to prove, and in this case it is prove that x equals 5. Here's our statement, x equals 5. How did we get to that statement from step number 2? Well, we divided both sides by 3, right? So the division property of equality is the reason that we can say x equals 5. All right, that's a pretty simple little proof. Let's do another. Oh, this one's not even drawn out for us. We have to do it ourselves, and we better get used to that. So all we're going to do here is we're going to write statements. And over here we're going to put our reasons. And of course we're going to number everything. And our first statement will always be something that's given to us. So we'll put negative 2x plus 1 equals 56 minus 3x. And of course our reason for that is because it's given to us. Remember, our reason is why can we say that? Why can we make that statement? Because we're told that's a true statement. All right, number 2. Let's see, we're trying to prove that x equals 55. I've always got to keep my eye on what I'm trying to prove. So I know from Algebra 1 that what I always want to do is get my x's on one side and my numbers on the other side. So I think what I will do is add 3x to both sides. So if I add 3x to both sides, then over here I'm going to have x plus 1 equals 56. And of course what I did is the addition property of equality. I just added 3x to both sides. And now what am I going to do? Well, I need to prove that x equals 55, so I need to subtract this 1 from both sides. And when I do that, there I have it. And so that was the subtraction property of equality. And there's my proof, 3 steps. They won't always be 3 steps. They'll hardly ever be 3 steps. But we're just taking baby steps right now. So we're making them nice and short. All right, maybe you want to pause right here and work this one yourself. I've done 2 for you. Why don't you try to set this one up and do it yourself? And when you come back, I'll have the solution for you. All right, so I've written the solution here, the proof. And please compare this to yours. Now, I know some of these steps you can do in your head because you've been doing this algebra for so long. Like, for instance, definitely from step 3 to 4, I would have gone ahead. If I were working this problem, just working it and not proving it, I would have said in step 4 that x equals 21. But when you're doing a formal proof, you cannot leave out steps. You can't do the steps in your head. You have to write down each and every step. I think this is one of the things that students find most frustrating about proof, but it's a necessary thing. So that's what you got to do. Don't leave anything out. All right? Here we go. Now, not all, but most of the properties we talked about related to equality, we have those same properties for congruence. So the reflexive property of equality for any segment AB, we know that AB equals AB. That's the reflexive property, right? For any angle A, we know that the measure of angle A equals the measure of angle A. Property. Oh, I'm sorry. I thought we were looking at congruence properties, but these are just the properties that we looked at a minute ago applied to segment and angles. So my fault. These aren't the congruence properties yet. All right, symmetric, if AB equals CD, then CD equals AB. If the measure of A equals the measure of B, then the measure of B equals the measure of A. Transitive property. what we're going to know here is that AB equals EF. And if the measure of A equals the measure of B, the measure of B equals the measure of angle C, then we know that the measure of angle A equals the measure of angle C. All right, so here we're being asked to write a 2-column proof. So we got to put our statements. And we got to put our reasons. Of course, the first statement is going to be, we have a lot of given things here. So what you can do is you can put, your first statement can be everything that you are given, if you want to do it that way. I think I'm going to just put the first given statement in my first statement. So measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, wow, plus the measure of angle 4 equals 360 degrees. And that's given to me. You know what? I'll just go ahead. I'll just go ahead and write all the given statements right here. Measure of angle 2 plus the measure of angle 3 equals the measure of angle 4. Measure of angle 1 equals the measure of angle 4. And I don't have to write given, given, given. Since I'm only making that one statement, I only need that one reason. Anytime your reason is the same for 2 steps in a row, you can combine those statements into one statement. All right, well now we got to do something here. What are we trying to prove? We're trying to prove that the measure of angle 1 is 120 degrees. All right, so I got to look at what I'm given, and guys, the important thing to remember about proof is that sometimes you just have to start writing things that you know to see if it gets you where you need to be. If it doesn't, then you have to backtrack and erase and try another plan. So what it looks like to me is I'm going to have to use some substitution. Otherwise, they wouldn't tell me they wouldn't give me these 2 statements if I didn't need to use substitution. And that's really all I can do. I don't have a figure to look at. So all I can think of to do here is to start using substitution. So what I'm going to do is I'm going to take the measure of angle 2 plus the measure of angle 3, and since that equals the measure of angle 4, I'm going to stick this right here. Or no. You know what? I don't want to do that. See, I'm already changing my mind. What I actually want to do is I want to take the measure of angle 4 and I want to substitute that right here. Because you see, I looked back at what I'm trying to prove. I'm trying to prove something about the measure of angle 1, and I've still got the measure of angle 4 in this step, so I don't want to go and eliminate the measure of angle 4. What I want to eliminate are these 2. So my next statement is going to say the measure of angle 1. Now, what I'm doing here is I'm rewriting statement 1, only I'm going to substitute in the measure of angle 4 for these 2. So the measure of angle 1 plus the measure of angle 4 plus the measure of angle 4 equals 360 degrees. So that's the substitution property of equality. All right, so now I've got measure of angle 1 equals the measure of angle 4. So what I think I need to do here, I'm trying to prove something about the measure of angle 1. So I don't want to replace this measure of angle 1 with the measure of angle 4. What I want to do is replace these 2 measures of angle 4 with the measure of angle 1. So what that's going to do for me is say I've got the measure of angle 1 plus the measure of angle 1 plus the measure of angle 1 equals 360 degrees. And that's also the substitution. All I did is substitute. Substitution property of equality. All right. Now what can I do? I can combine like terms, right? So 3 times the measure of angle 1 equals 360 degrees. And of course, that's just combined like terms. You could also write simplification for your reason. I just prefer combined like terms. All right, and now I got it, right? What have I got to do? All I got to do now is divide both sides by 3, and I've got what I'm trying to prove, which is the measure of angle 1 equals 120 degrees, and that's by the division property of equality. So you might need to take a minute and let that soak in, and then we'll do one more and we'll call it a day. All right, here we go. So let's set up our table, our 2 columns, statements, reasons. Number 1, of course, we're going to put what's given, and that is B is the midpoint of segment AC, and C is the midpoint of BD. That's all given to us. And that's all that's given. And what are we trying to prove? We're trying to prove that the length of AB equals CD. All right, what I want to do before anything else is I want to mark my figure here. If B is the midpoint of AC, then I know that AB is congruent to BC, right? And what else do I know? C is the midpoint of BD, so I know that BC is congruent to CD. All right, so marking that really helps me to think what my next statement needs to be. I'm going to look at my drawing and I'm going to say, well, okay, since B is the midpoint of AC, I know that AB is congruent to BC. And since C is the midpoint of BD, I also know that BC is congruent to CD. How do I know that? This is where, if you haven't been memorizing these definitions, postulates, and theorems, this is where it's going to get you. How do I know these segments are congruent? Because that's the definition of midpoint. The definition of midpoint is a point that divides a segment into 2 congruent segments. Not equal segments, congruent segments. Definition of midpoint. Okay, now I feel like I've shortchanged you here a little bit. I did think that I had the congruence properties in this lesson. I think they are in this section in the book, and so hopefully you did make flashcards for them. But there is a transitive, just like we have a transitive property of equality, we have a transitive property of congruence. And what we don't have is a substitution property of congruence. Anyway, we'll talk more about these congruence properties in class since they were not in this lesson, but you have to know right here that we do have a transitive property of congruence, and what we can see is that we need to use it. If you look at step 2 here, AB is congruent to BC, BC is congruent to CD. So what I can say, because of the transitive property, is that AB is congruent to CD, right? Because AB and CD are both congruent to BC, therefore, by the transitive property, they got to be congruent to each other. So transitive property of congruence is why I can say that. And boy, that's awfully close to what it is I'm trying to prove, isn't it? But I'm trying to prove equality. I'm trying to prove length. So all I have to do right here is say that AB, oops, not segment AB, the length of AB equals the length of CD. And why is it that I can do that? Because that's the definition of congruent segments. Congruent segments are segments that have the same length. So all I got to do to change from congruence to equality is use the definition of congruent segments. So this proof right here is much more like the type of proof we will be doing for the rest of the year. We won't do many more algebraic types of proofs where we're proving that x equals a number, but we will be doing this type. So please, please read your book. Make note cards, flashcards for all these properties of equality and all the properties of congruence, because we will use all of them next time. We'll do many, many proofs. So I think that's it. Summary is actually on the next page. So write that summary, study this, let me know next time what questions you have, and we'll just work a lot of proofs in class.